Hi, if you are watching this version of the talk, it means that my kids were not allowed into their daycare. So we're going to talk about growth stages of mid-Atlantic grain crops. I know in the description, I included sorghum in the description. I actually ran out of slides. I didn't think I could fill this whole thing, but I did with corn, soybeans, and small grains, which is mostly what we grow. And sorghum's so similar to corn, you could follow those stages that way. But when you're looking at growth stages for farmers, it really helps in decision making. So I know we have a range of people that attend these, and you might just be interested in being able to communicate or understand what stage something's in a field. And what growth stages help people do is make decisions. One, you'll see it definitely with corn, decisions on nutrient application when we talk about side dressing nitrogen. It's certainly disease scouting and prevention, because you're going to have different diseases early in the season versus later in the season, like when you have early growth versus seed head formation. And then insect thresholds and economic damage, how to take a look at some of these and decide, are you going to apply something or not? Because sometimes you reach stages where there's not much you can do about it, or it will recover. And some of the earlier stages, things will recover from damage. When you're going to terminate cover crops, when you're going to harvest. So there's all kinds of things, reasons to understand growth stages. And it's not necessarily very hard. You'll see that soybeans and small grains are a little bit more difficult. It's just useful to be able to walk out there easily and take a look at some of these. So first we have to start off with some general plant parts. So roots. Then we also have, of course, the stems. You have to be able to recognize the stem. You're going to definitely see this with corn. You have to be able to tell the difference between a stem and then a leaf, because the leaf, you can see right here, the leaf where it attaches to the stem. Same thing with corn. Of course, your leaves, flowers, when the start of reproduction, the actual reproduction, the fruiting part, but we're not going to cover this part because we're talking about grains in this case. So we're going to get to the seed formation. The seeds in this case are inside the fruit. So sometimes we call this the fruiting part of the plant, but it's really the seeds for these crops. So if you don't remember this from biology, and I'm a soil scientist, I'm not a plant scientist, but still it's good to remember some of this. Monocots versus dicots, because we plant both of these. And corn's a monocot. It has fibrous roots, and it doesn't have these two cotyledons on it like soybeans do. They're a dicot and they have a taproot. So monocots have one cotyledon and a fibrous root system. So corn, wheat, grass, onions, tulips. And then dicots have two cotyledons and a taproot system. So if you've seen tillage radish, it's one of our more famous, things that have a taproot because it's so large versus soybean. But if you pulled a soybean out of the ground, you have seen at the base of it more of a taproot with some fibrous roots coming off versus corn, which is going to be very fibrous. So legumes, cabbage, carrots, peppers, broccoli, they're all dicots. And so here's when we have pictures of soybeans, you'll see it more clearly. These two cotyledons coming off of here. That's the difference between these. So corn is a monocot, soybeans a dicot, and of course our small grains and grasses are all monocots. So in terms of germination, here's your corn germinating. So here's your monocot germinating, and here is your dicot germinating. You can see some difference in those and what pushes up to the soil. Then your root system, here's a fibrous root system. And then here is your taproot system. So here's a tillage radish. This is a very obvious taproot compared to soybeans. Soybeans have a small taproot, but you can see it if you pull it out of the ground with fibrous roots. And there are some fibrous roots coming off here, but it's mainly a taproot plant and stores a lot of energy in there. So some general stages in terms of plant development that we're going to talk about, because these are going to follow the stages as we go through there. You have germination. When you break, seed dormancy is broken and begins emergence. Well, this happens under the soil, so you're not going to see it, but it's occurring. It happens beneath the soil surface, but germination is occurring. When you plant that seed, you're not going to see it till it emerges from the soil, but germination has happened below there. And once germination and we break through the soil and we have the emergent stage, then we get into the vegetative stages. That's where it's doing all the leaf production, and the leaves are what it's getting energy from to transfer that energy into the seed. So developments of roots, shoots, and leaves. So this is a major portion. It's the first half of the plant's life cycle, and it's mostly what you're probably used to looking at early in the season. And then reproductive, that's where we start flowering, and then we form the fruits and the seeds that develop through there. So vegetative, what you're going to see, what happens with vegetative is it just keeps adding leaves, roots, and shoots, because it's trying to get water and energy. It's trying to build itself up to get to the reproductive stage and to feed into that seed production. So vegetative versus reproductive. Our vegetative stages, here's our leaves on the dicot, and then of course there's corn, our leaf production. So, and your root production, because your roots are getting water and nutrients out of the soil, and your leaves are used for photosynthesis and pulling energy from the sun. And then reproductive, that's when we start forming our seeds. You start to see the seed formation. So we have flowering. These little anthers on here, those are the flowers on wheat. That's actually flower. And same thing here when you have these silks coming out on the corn that are pollinating. Before we get into the actual stages, you do have to understand what growing degree days are. And so you'll see GDUs or GDDs, growing degree days, because temperature is a major variable in the growth and development of plants. And because temperature varies daily, we can't just measure days from planting. You can, but it's not gonna match every single time, because if you plant in April versus May or June, this corn plant, well, April's so cool that the corn's gonna grow slower because it doesn't have the temperature behind it to help push its growth. So what they figured out to do was they do a calculation to figure out how temperature affected growth that day. And we do that for a lot of crops. It doesn't work as well for soybean, but it does work very well for our grasses like corn and small grains. So growing degree days measure heat accumulation. So temperature, if it's warm enough, how it accumulates over time, and it's individualized for each plant. You can't take the growing degree units or separation of stages and apply it to different plants. Each one's going to have its own response to temperature. So it's also, you'll see it called GDUs in some places. So here's how you do the calculation. And if you've ever gone to DEOS, the Delaware Environmental Observatory System, they do the calculation for you. But you're going to take your maximum temperature, your minimum temperature, divide it by 2. So you add those together and divide it by 2. So you're kind of getting an average, and then you subtract that base temperature. And your base temperature, what it's going to be looking at is the minimum temperature where a plant will grow. So it's going to be specific for each crop, because you don't really care what's going on below a certain temperature range if the plant's not growing at all. And I should have an example of the calculation next, so you can see what that base is. So the maximum minimum temperature are daily temperature readings. Whatever the max and minimum were, you add them together, you divide by 2, and then subtract the base temperature that applies to that plant. So you can exceed maximum plant growth. And we'll talk about that in the next slide. But like for corn, 86 degrees, we don't usually count temperatures over 86, because then it starts hurting the plant. And that's what we call the modified GDD, or you don't want to go below minimum or exceed the maximum, so they modify it. So if you're not modifying it, then you're not including the base temperature in there, but we want to include this. We want to check into so we can be more accurate. And so the base temperature for small grains across the country is a lot of people in Oklahoma State and places like that use 40 degrees Fahrenheit, where Virginia Tech uses 32. And what that means is below 40 degrees, we don't get a lot of plant growth for small grains. So if you look at this, if your max and min divided by 2 is equal to 40, and your base temperature is 40, then your GDDs for that day are 0. And you don't count it. The same thing's going to go for corn. So for corn, 50 degrees is our base temperature. So as long as this average of the max and the min are above 50, you're going to get a GDD. If this number comes out to be 50, and your base temperature is 50 for corn, then we don't get any growing degree days. So if you're into early April, if you're into mid-April and planting, some days you're going to be above this and some days you're not. But once you hit June, if you can't plant till June, well, it's very likely that your temperature is always going to be above 50 on average. So you're always going to get growing degree units. So you're always going to see some growth. And that's why we use this instead of days from planting, because if you plant in April, you don't have the temperatures to push growth. On the on the other end of that, we don't use anything over 86. They don't use it. It has to be modified out because above 86 corn slows down growth. And this is pretty much used for all of these crops, except for soybeans where they say 85, but it's 1 degree off, or definitely 99 degrees is when it really shuts off. So it slows down here and it shuts off here in that range. So this is a graph of some data from growing degree days from Delaware that we've collected. So if you go days from planted, if you plant in early, mid-late April, you're going to see that it took 40 days to get to V6. But if we plant in early June, it only took 20 days. That's why you don't go days from planting, because it was so much warmer. It only took 20 days to get to the V6 stage versus 40 days for mid to late April. But if you look and you convert that to the temperature that's going on, you see that they get a lot tighter. They bring themselves together versus how spread it out it is here, because you're normalizing it. You're looking at what the temperature was and how it added up and how it got to that stage. So there's other things that go on here, moisture, planting depth, all kinds of things that separate this out. But you see how much tighter this curve is than if you go days from planting. So certainly it's valuable to know, to be able to tell someone, well, if you plant early to mid, if you plant mid to late April, it might take you 140 days until you get to Blacklayer, until you get to be able to harvest at R6. And we're going to cover all these stages for corn. Versus here where it takes about 110 days when you plant, let's say early May, when you get into this zone here. So planting in early April or mid to late April, yeah, you get out there early, but it takes a lot more days to get to the end if you don't have the right temperature units. Growing degree days just helps us compare better what actually happened. So this is some data we have for Delaware, just watching the fields over the last couple of years. If you go by growing degree days, that calculation, remember this is GDD, this isn't days, it's how the temperature accumulation, but 84 growing degree days to 150 to emerge. And it's pretty standard. This matches what they see out west. By the time you get to tasseling, about 1300, R6, you can see there's a range because there's different factors that affect. It can include the hybrids themselves, the corn type that's going to respond. So growing degree days, though, they really work best with corn. The temperature definitely affects soybean growth, but they really respond to night length when they go into flowering. So yes, temperature is going to affect when it germinates, and it's going to affect the leaf formation. That's definitely a factor, but really our soybeans are going to flower by night length. Winter small grains, what we've seen here is when they undergo a freezing event, it kind of cuts it back. There's different calculations they look at growing degree days since January 1st, because you can have small grains rapidly accumulate. If we have a warm fall up through December, they'll accumulate growth, and then a freeze can knock that back, and then they kind of start over. So it doesn't always work the best with them if you can't account for temperatures that might kill some of the leaf growth that it has to recover from. So it works best with corn because corn responds to temperature. It doesn't respond to night length. And we plant corn in May, so you're not likely to have these freeze events. But we do use growing degree days for cover crops. We use them for everything. It will work best with corn. So we're going to start with corn. Corn is one of the easier ones to look at. I have and also have a lot of pictures of corn because we do so much work with it. So if you look at emergence, and we said it takes about 184 to 150 growing degree days around here. Well, that's about 5 days to 2 weeks if you look at it in days. So when's 5 days? This is if you plant in mid-May. This is if you plant in mid-April. Pretty consistent, this is what we see. Mid-April, it's almost always 2 weeks, 10 days to 2 weeks. By the time you get into May, it stays warm long enough, you can get it in 5 to 7 days pretty easy. It's very hard to see emergence. So emergence, it germinates under the soil, but you don't see it. Emergence, this early stage, look how pale that is and how much it looks like. So you have to be walking slowly and walking these rows, because one might pop up first and a day or two later, you might see a couple more of these seedlings emerge out of the ground. This stage is where you start to be able to see it, but you can still miss it. When you get here, what you're going to see is we're starting to have that first leaf formation. You can see that first leaf right here forming. And so you're right on the edge of what we're going to talk about is V1 versus VE. So this is VE, this is VE, and this is getting to be, whoops, that's not very good, VE to V1. It's moving into V1. And people don't always say this, you won't see the notation this way, but I actually, when I'm in the field and I'm doing research numbers, I do different ways. I use a squiggly line that tells me if I think it's about to transition versus this VE/V1 where there's enough plants that are in between the stages that I think it might be V1 tomorrow. It's a note to myself. You don't need to do this. It's more of a research thing so I can get an idea of how close was it moving towards V1 like this is, or was it going to be V1 tomorrow? Because I don't know if I'm going to get back out in the field and check it again if I have time to do that. Once we get into these vegetative stages, after emergence, we have to start looking at leaf collars. You have to be able to recognize this. And what you're going to see with a lot of this is it's subjective. So when you go from VE to borderline V1, how do you tell the difference? One thing I should point out is that at least 50% of your corn should be at this stage before we call it VE. If you only see one coming out of the ground, that's not VE because you only have one seed leaf. Because all these seeds, they might be planted at different depths. They might just react to different moisture contents. It's not going to be consistent across the field. So the way we look at these vegetative stages is we look for leaf collars. So if you look right here at this leaf, it's attached to the stem of the plant like this. And once it gets to right here, it bends off. So it comes up and you see it bending off. And that is where you have your collar. And if you see right here, there's this little white line. And again, just like with emergence, this little white line where this leaf kind of bends off, it can happen within hours. It can happen within a day. You might miss it. You might come out and it's not there and then it's there next. But if you're not doing research, if you're not really trying to specifically say when it occurred, it's not a big deal. You might say, well, I think this is going to happen tomorrow. So you can go ahead and call it V1 or V2. So the collar is where the blade and the leaf and the sheath join. So right in here. It's easier to see with later stages. I think V1 is hard. It doesn't, V1 comes on really fast and it moves into V2 pretty quickly sometimes. It's easy to miss. So you got to look for that visible crease. It's what I call that. It's just this little white spot. Now you might talk to an agronomist out in Minnesota. You might talk to an agronomist at Virginia Tech and maybe they call it a little differently. What you really want to do is whatever you do, you be consistent. All year long, you call it the same way. The same thing as if your entire life looking at crops, you want to make sure that you're just consistent in how you call these leaf stages. This is how I do it. I look for the visible crease. So here you can see it, but here you don't. It's getting there, but it's not there. So then your next question is, it looks like it's starting to form right there. Your next question is, well, when is it going to happen? So this is when I leave notes to myself. This is V1 and I'm like, okay, it's moving to V2. I'm not quite sure when it's going to happen. It might be tomorrow. It might be in 2 days, depends on the temperature. Whereas here we have a collar and then there's another collar. So that's definitely V2 because we have 2 collars versus 1 collar. So this is an art. I mean, it's not really a science. They don't always say that. When you read all the documents or you learn about it, it makes it sound like we really know what we're doing. But this is where it depends on who you are. It's like I was saying, just be consistent. Once figure out a method, how you want to call it, and just be consistent. Because I have a feeling it's the same thing with calling soil horizons. Soil pedologists are going to be different. Agronomists are going to be a little different. I just make sure I'm consistent. When the leaf starts to droop, like this one's starting to fall, see this one's still straight up, that's your third leaf right there. See, a third leaf's already out, but your second leaf doesn't even have a collar yet. That's how difficult this can be. So you just want to be as consistent as possible. You really only learn by doing. That's anything in agriculture. If you're here to just be able to talk and understand, well, that's fine. If you want to do this, you just have to do it. Year after year, get out in the field and call and look at the crop and look at it the whole season, and you'll get better at it and you'll be more confident. But if you look right in here, you have 3 collars. There's 1 collar, there's 2 collars, there's 3 collars. There's your next one. See, this leaf is straight up. It hasn't even started to droop yet. And then there's your 5th leaf. It's coming out already. So you're going to have 5 leaves out, but you only have 3 collars. And that's why they had to come up with a method like this. How do we be consistent? Okay, we're going to say if we see this collar, we're going to call that V3. Somebody else in some other time might have called this V5. Like if you see the 5th leaf, it's V5. But the reason this is important is because everybody does it this way. Pretty much everyone looks for this collar, which means if you see on an herbicide label, it says don't apply past V4, you can know that means count the collars versus looking for 4 leaves. Because in this case, you'd have 1, 2, 3, 4, 5 leaves, and it's not V5. It could be if someone decides to trash this system and completely redo it, which isn't going to happen. That's my point, though. It's made up. The whole thing is made up. So just understand what people are saying and then try to do as similar as possible. So you're likely to miss the collar appearance by a day or 2. I can't come out here every day to some of these sites. I'll miss it. I have to take a guess from walking out there. So I definitely call this V3 because this isn't even close to drooping. So V3, when's V4 going to happen? It could be 2 days. It could be tomorrow. It could be 5 days. But if you aren't doing phenotyping research, who cares? If you're just trying to get in the ballpark, then you're close enough. Because the leaves might not droop before you see the collar. The older that plant gets, it actually, see that collar? It's not white here, but it's there. And see this leaf is still straight up. When you get to about V9 or V10, you don't see it droop like this. You don't see the leaf fall in the collar form, because it starts putting out leaves fast. It has enough energy. They're more upright, and you just have to look and see that collar line there. You have to look for that line. That's how I do it. That's how I call it. So for corn vegetative stages, you have to count these leaf collars. So this is 1, and then 2, you can see it connected and drooping off, and then 3, there's that line. Here's 4, it's straight up and down. So this plant is V3. So that's how we do it. You just got to be as consistent as possible. So now, after all that discussion, we're going to get back into what these actual stages are. So here's your VE. I can see the leaf, right? There's that first leaf formation, but there's no collar yet. This is still VE. It's drooping a little more. I can see it. It's coming off that. It's coming off the stem some right here. There's that collar. So look what it had to do. How much more growth? It had to come up and then drop that off, and it's already moving into V2. And V2 right behind V1. There it is. Very similar looking plants. So I think V1 is hard to find unless you're going out in the field every day. Emergence, you can see sometimes by the time you get out there, it's already moved into V2 pretty quickly. That's my experience. So V2, V1, the other thing to remember is that leaf collars are on the opposite sides. Wherever this leaf is, then V2 is here, V3 is going to be here, V4 is going to be here, V5 here, V6 here. It's going to do it all the way up the plant. So that's another way to look. If you think you've got 2 on the same side, then 1 leaf might have been ripped off. So V2 to V3, that thing about the 50% rule that we discussed earlier, here's 1, here's 2, here's 3. Here's 1, here's 2. Look, that one's starting to go, but it's not there yet. Same thing here, 2. 1, 2, here's 3 and 4, but they haven't formed a collar yet. So 2 out of 3 of these here. So this is V2. But this one's already at V3. These might be at V3 in a day or 2, and then you're going to have to move it in. So it's easier to catch V2 than V1. Even though this is V2, V3, and you can see V4, V5 leaves, that's why you count the collars, to be consistent, because all these corn leaves, here's 1, let's see, 1, 2, and 3, 4. It's much bigger, but there's that little one, so that might be V3 down over there. You just got to be consistent. Once you get past V3, the leaves really start coming off. It starts to grow faster. It feels slow. VE to about V4 feels pretty slow. You're going out there and checking. It doesn't move very fast. Past that, it can really start putting out the leaves if you're not paying attention, because the temperature usually picks up. So you get these leaves on there. This one's easier. 1, 2, 3, 4, 5, 6, 7. So by the time you get to the stage, you're at 7. One thing I should point out, I probably haven't mentioned before. I don't know if I mentioned a slide after this. So your lower leaf, your V1, the other thing about it, it's got a round tip. Let's go back. Yeah, see this right here, your first leaf? Let's erase all the ink on this slide. See how this first leaf is round? All your other leaves are going to be pointed like that. So if you don't see that leaf, if you come out here and forget to stage until you get to about V4, but you don't see a round leaf like this one, or down at the bottom, a round leaf, you've already lost it. So you're actually a stage behind. And that's the point of this next slide. You will lose leaves later in the season. If you think, well, I'll go out and count when the corn gets above my head, and you're not going to count correctly, because here, this field must be low in nitrogen. See that leaf, that V1, it's going to be gone very soon before you even get to V4, V5. That leaf is dead. It won't be there. You won't be able to count it. And same thing here. These are nitrogen troughs. We have lower amounts of nitrogen. These leaves are dying. The other thing is, once this corn gets tall in canopies and there's shade, there's no use for these. They're not producing as much energy. They'll actually steal as many nutrients as they can and pull it into the upper canopy. So when you have stress, you're going to lose leaves. So if you really want to stage your corn, you got to go out early and often. One thing that you can do, and I've done, because you can definitely lose these, is if you write on these with a Sharpie, it sticks around. See, 1, 3, and there's 2, 3, 4, and there's 5. I also like to write on the inside of the stem, because you can see it says 9 and 8, the 7. That helps you, because you're going to lose these leaves later on. And I have a flag next to a plant, and that's how I keep track for my research projects, just so I can make sure I know the approximate stage it was at when we recorded certain data, because you're going to lose those leaves. Once you get past the vegetative stages, then you're going to get into the reproductive stage. And these reproductive stages actually start of VT is vegetative, but it's really borderline on the reproductive. So they call it a vegetative stage, but it's when the tassel is going to come out. And the same thing, you have to have 50% tassels emerging across the field. And you'll see a couple, and this stage can happen really fast. It can come out, you'll be waiting, and then all of a sudden that whole field will be tasseled out, especially if you're trying to match up tissue sampling across there. Reproductive stages begin really shortly afterwards, after this tassel appears. So this tassel is where your pollen is, that's going to drop down on the corn and fertilize it. And these silks are going to catch your pollen. So that's why R1 is considered silking as our first reproductive stage. So we're out of vegetative stages now for corn. It's not going to produce any more leaves at this point. It's now going to start using all these leaves to feed into the seed production. So you're going to have pollen dropping down onto your silks, and the silk's going to move the pollen down into where the kernels are going to form, and it's going to pollinate. So that's R1 for corn, your silking stage. After silking, you get to the blister stage. So at this point, everything's been pollinated, and you can see where these silks were attached on there, and they start to come off. Your silks are going to come off here, and we have these little blisters on the tip of the corn. This is another stage that's actually hard to catch. It can move out of this decently fast. The silking's easy, but you'll still see silks on here, and you're going to think, oh, it's still an R1, and it's already moved past that. You only know at this point by pulling an ear off. So for me, it gets more difficult. Instead of following vegetative stages and having numbers written on the corn, you have to start pulling ears off and open them up. So your silks are going to turn brown and dry, and white blisters form on the kernels. And what you're getting after this is you keep these kernels they're pollinated, and they're starting to fill. And so the R3 stage is the milk stage, because inside of this, as they're starting to fill out, you have this more of a liquid inside here. If you puncture this corn, it's going to have a watery substance come out. It's going to be white in color, so they call it the milk stage. So your blister bump is gone. You have these kernels, but they're very soft. So this is like eating sweet corn at this stage. You can eat field corn at this stage. So blister bump is gone, and your kernels are going to swell. The milk stage is the whitish liquid, and your moisture content is about 80% at this stage. Then you get in the dough stage, because now it's swollen out, it's filled up, and it's drying down. You can't tell, except for you might see some denting. So I picked out a picture that shows a little bit of denting, because now that it's drying out, think about how some things dry and they collapse in on themselves. So they filled up and now they're drying down. So they're going to lose some of their surface, and that's where these dents come from, where it dries down. So these are now getting drier. So if you cut them open, they're going to feel like dough, like bread dough or biscuit dough, anything like that. Then you get into the dent stage. That's R5. So once you get to R5, the majority of the ear, maybe not all of it, some of the kernels aren't, but it usually starts in the center and moves like this. You're going to have these dents across all the ears. And what you have, you see this milk, what they call the milk line. So here's your embryo. On the butt side of the corn, which is down here, clear this off again. So you got your tip side, and you've got your butt side of the corn. And this is important to remember, because when you bust this corn open, when you rip it in half like I've done, the tip side is where you see your milk line. And see this kind of line going across here? This is your corn drying down. So here we have milk, and here it's dough. It's dried out. So when you go into the dent stage and you're really drying this corn down more, you're going to see this line continue downward as it dries the corn out, which is actually why they technically have R 5.25, 5.5, 5.75. And what that means is, if you're at 2.5 and about 25% of this kernel, if you're at 5.5, it's 50%. If you're at 7.5, it's really close to the edge. And this isn't the best one. You can see that milk line though, that goes across here. We can trace it some. So this one's about 5.5. It's about halfway across that kernel. It's tough to see it, but it's helpful because you want to know how quickly it's drying down. The butt side of the ear, this lower side, that's where you see the embryo at. That's where your seed's going to grow from. It's showing you the embryo. So look for the milk line on the tip side. Break that ear in half, and then look on this side of that tip. And that's where you're going to see your milk line. Then we get to R6. This is what they call Blacklayer. It's physiological maturity. This stage, to be honest, everyone shows you these nice pictures of Blacklayer. It's not easy to see Blacklayer. And that's that black that we see right in here. And sometimes you actually have to pick off a little bit of the whitish substance to see it. And you might check and not find it, and then a day later you chip away, and this is where the seed's separating from the cob here. It's pulling off. So the tip of the kernel is going to be black. At this point, it can be harvested. It's probably the moisture's too high, but it's considered to be physiologically mature. So you can harvest this corn at this point. So corn we went all the way through vegetative through reproductive. So this is your harvest stage. So we'll jump right into soybeans. Just, no reason to wait around. We'll just keep moving right through. We've already talked about corn emergence, and we talked about vegetative stages, so we can kind of get an idea of what's going on with soybeans. I don't find soybean emergence to be as clear, because they have some stages that seem to overlap, or the names of them would probably not make sense. Again, soybeans are a dicot, so the cotyledons emerge first. That's your VE and VC. V1 is when your first fully developed compound leaf emerges. And I think I go into much more detail. So this will make sense in a second. But you can see this emergent stage, you got VE, VE, VC, V1. And that's something that corn didn't have. It didn't have this VC or cotyledon stage. It had emergence, and it goes straight to V1. But soybeans are a little different in how they've described them. We could this is just made up. This is created by other scientists. You could make up your own if you wanted to have your own personal system. And I kind of do, because I don't quite like how this is the VC stage. So here are your cotyledons right here. And this is your unifoliate leaf. So it's these leaves right here are unfolding. See the leaf in there? That's what's right here. These 2 leaves are going to unfold. So your cotyledons are right down here. So your VC stage is actually referring to these leaves that have folded out, these 2 leaves. So yeah, it's 2 leaves, like you have 2 cotyledons, but it seems like if I did it, this would be emergence, this would be VC. I don't know what you'd call this. I think what I call it is, I call this VE2. That's my own system. You can do whatever you want. I mean, if I tried to put this into a publication, I'd get ripped for it. I couldn't do it. But in the field, because I want to know the difference between when it hits this and when it hits this. So I call this VE2 just for my own personal satisfaction. Now, I'm not a soybean expert. Whoever came up with this could probably explain why they did it, but I just like to be clear to myself because I don't think it's necessarily makes sense. So this stage is your cotyledon stage. It's an unfolded unifoliate. So we have trifoliates and we have unifoliates. And the difference is going to be we have 2 leaves come out. So your cotyledons come out first, 2 cotyledons, and this right here becomes 2-leaf structure at the bottom of the plant. V1 is our first trifoliate. So 3 leaves on a compound leaf. 1, 2, 3 leaves. So here's your leaves on the bottom. See over here too, there's your shiny cotyledons, very shiny. You have this unfolding. Here's your unifoliates, 1 and 1, and here's your trifoliate leaf right here getting ready to unfold. So it's the first fully unfolded trifoliate leaf, unfolded. This doesn't count. It's not unfolded. This counts. It's unfolded. So again, it's kind of like corn. How are you going to decide when something's unfolded or not? What if this leaf's a little bit higher than the other one? What are you going to do? You got to be consistent. It's an art. It's not a science. It's a guess. And no matter what they tell you, the books make it seem clear. It's not clear when you're in the field because it changes. Just be as consistent as possible. This is where soybeans get tough. Like corn, each leaf's added like this. It just climbs up the plant. Easy to count those collars, not soybeans, because you have to look for those fully unfolded leaves. You can have deer damage, all kinds of stuff going on. And if you notice, sometimes your newest leaf is down here and your older leaf is above it. Especially if you're trying to do tissue sampling and they're like, get your most unfolded leaf. You can actually have leaves that are older, that are higher than the youngest trifoliate. You have to reach down into these plants and check where that stem is attached at the node. Soybeans, the leaves they get above themselves, and the newest ones are always below the older ones. So it's not easy. You have to take your time with soybeans. You have to open up the plant, and it's not like corn where they're all separate. They're just all mixed together. The leaves from this plant are over on that one, and this one's over on that one. It's a pain. You have to take your time. So if you're like me and you're doing too many projects, it's not fun when you got to slow down and figure out a leaf. Ear leaf on corn, that's great. When you're collecting the ear leaf, you just walk down there. There's the ear, rip that leaf off. Not so with soybeans. It's a lot tougher to do it right. Damage to leaves can throw it off, and this is also where it gets more difficult. See, corn has one growing point, and if you cut that off, it quits growing. But you can always figure out the leaves are, but not with soybeans. Deer eat this leaf off, well, it's going to spit another one off off the side. You cut off that edge, it might add some things to the side. So it gets difficult. That's a great thing about soybeans. They're elastic. They can respond to early damage like deer damage and spring up and add more leaves. That's why we love them. But if you're trying to stage them, it makes it a lot harder to do. So you have to search for damage and leaves by looking at the nodes. So where it attaches to the plant, and you have to see where that node was, because you're going to have a node coming off the main stem, but these side nodes are just a response to deer damage. Sometimes you have to, again, if you've had deer damage, you're going to have to take even more time to check that plant to figure out what stage it's at. This gets to the point where we have to talk about something else about soybeans, how we have indeterminate versus determinate soybeans, because indeterminate soybeans continue new vegetative growth after flowering. And that's because they're from Delaware North in cooler climates, because because it's cooler, we might plant them later and they don't get as much vegetative growth to feed the beans. So they just keep spitting out leaves. Even after reproduction grows, they'll keep putting some leaves out for a little while. Determinate cease new growth after flowering begins. And these are typically 4 or 5 or greater groups. And we do plant some of these, but south of here, where it's warm enough that you planted earlier and it can get to a certain stage and have enough leaves so it quits growing. Whereas indeterminate beans keep putting leaf growth off. So this is important because once you see the flowers forming, we're in reproduction. But you might come out there and say, wait, it's still putting leaves off. It's still in vegetative? No, you see the flowers and we're moving into reproductive stages. It's not like corn, which stops leaf production. It's going to keep producing. So soybean reproductive stages are going to go with flowers. R1's easy. One open flower at any node on the main stem. Man, it's easy. You just go out there and you look and you'll see a tiny flower and you're like, all right, I'm at R1. R2 is an open flower on one of the 2 uppermost nodes on the main stem with a fully developed leaf. R1 happens early. R2 takes some time. It might not happen quite as quickly. You can see R1 across the field, and then you'll wait and wait and wait because you'll see other flowers form. You have a flower down here and a flower down here, but no, uppermost nodes, fully developed leaf. So it takes a little bit more time. It gets even harder, I think, with trying to tell what these pods are, because R3 is when your pod is 3/16 inches long. Well, you gotta have a ruler with you. It's not like looking at the corn and being like, oh, okay, it's a blister, it's got some milk, it's got some dough, I see some denting. Now all of a sudden you have to have a ruler with you. R4, pod is 3/4 inches long. So you can see these pods. Here's a young pod. But you have to measure them because it's hard, when they're starting to fill out and add beans. R5, seed. Now you're into seeds at R5, 1/8 inches long. R6, seed is green and fills pod cavity. R7, one mature colored pod on the main stem. R8, 95% of pods, obviously this is right before harvest, are mature. They've browned and matured. So soybeans, fun plant, not easy to stage. It's easy to stage early, but once those leaves start popping off, once you get into these reproductive stages, you have to take your time. You have to, this is what I do. I take lots of pictures. That's what I do. You see in my research project, we had a soybean timing study. You see where I wrote on my hand, put a 3 on there. So I could take a picture and I could measure stuff later. I can look at it later in case I don't have time. But you can see as these seeds form and they get larger and they fill out the pod, it's still subjective. But again, if you're not doing research and you're just trying to generally know, well, when am I going to harvest or what stage is this at in your scouting? Well, it's good enough. It's more if you're trying to figure out what happened at this stage, if you're a researcher, that you really want to be accurate with this. One of the best guides out there is always going to be Wisconsin. They have a great soybean program. They really have a solid program, and they call it Cool Bean, but this is from 2017. But everything I've said in here is in much more detail in their guide. But what I like about this image that I took from there, they were talking about how you can find all these stages in the field at one time. But this is R3, but this is R4. Well, look at this. There's 2 in between. What's that? R3.5. Here's R5. You got some here. Look in between. And here's R6, really? So it's subjective. There's constant growth. It's a constant change in this plant. So don't worry if it's difficult to do. It's okay. You're just trying to get within the zone, and someone's gonna say, nah, that's still R4 and this is R5, and someone's gonna say, you know what, that looks like R6. It's gonna be different depending on who you work with. Just be consistent. So soybeans, tough, great plant, tough to stage later in the season. Small grains, you're going to find that they're not as tough as soybeans, but because they put off these tillers is what makes them hard. So small grain emergence, easy. Emergence is the easiest part of the plant. You can go out there and see VE all day long, right? So your emergence stage. Small grains actually follow the Dicots or the Feek stages. So the Dicots or Zodux is going to be very specific in how many like leaves. It's better for research. Most people talk in feeks because it's easier to say them and it skips a bunch of stages in between. This is probably what researchers usually use because it's going to tell you how many leaves were on there specifically. So something that has 3 leaves is still Feeks 1, but is actually Zodics 1, 3 because it's the first stage, but it has 3 leaves. So it's at that stage. So it's more specific, and you probably will be used to talking about Feeks, whereas researchers are going to use Zodics a little more. So first you start off with your emergence. You have the plant emerges out, and it's going to form 3 leaves. But then what small greens like to do is they add tillers. Now, so does corn. Corn has tillers. It's just they're not always as important as they are in small grains. So once you have 1 leaf come out, you have the main stem. Let's say this is the main stem. Well, it's gonna shoot off. In this case, it has 3 more stems on it. So it's tillered out. It's created these tillers on the side, and each one of these has its own if it makes it to harvest, have its own seed head. So 1 wheat seed can produce 3, 4, 5, 6 different heads on it, depending on the fertility of your soil and the quality out there. So tillering is when you start to see these stems come off. Well, this isn't corn or soybeans. It's not very tall. That means, I don't know if I have a picture. Yeah, this is what you're going to be doing. You're going to be down on the ground taking a look. Now, this hasn't reached tillering. This is where we're just counting plants, but we're taking out measuring rods and trying to figure out how many plants there are, and then eventually come back and count the tillers. And it's a pain. Counting tillers is time consuming, and you're only supposed to count tillers that have 3 leaves. So that's another problem if you don't know how to do this. If you're trying to count tillers to figure out, well, not only am I at the tillering stage, but how many tillers do I have? Well, if this only has 2 leaves, but you're in a hurry, this one actually doesn't count. So this only has 1 main stem and 2 tillers. That would be technically what it has. And it's very easy for these things to have extra tillers that have like 1 leaf on them. But if it has less than 3 leaves, it's not likely to form a seed head, so we don't count it towards yield. So once you get past the tillering stage, so tillering happens, it's going to tiller out right before winter, and then it's going to go into a vernalization. It's going to go into hibernation. And then when it starts warming up a little bit I'd say about February, it's going to start putting more tillers out again until it gets to what we call more of the green up stage. So I don't have, obviously, I take lots of pictures of the tillers and then I take pictures later in the season. I didn't have a really good green up picture, but it's hard to get wheat and small grains are so tight together. But it just means that it starts growing upright. If you come back here, you'll notice that it kind of just branches out to the side. It grows these tillers and spits out to the side. It stays low. It doesn't get very high if you've walked in a wheat field over the wintertime. But once we hit March and you get to stem elongation, it starts growing upright. It stops forming extra tillers and it starts growing upright. And so it quits creating new tillers. It grows upright. That's stem elongation. The end of this stage is going to be what we call the flag leaf stage. And I have good pictures of the flag leaf somewhere, but I couldn't find them. But you see this leaf, it's right before the seed head comes out. See how it's like a flag. Once you see one of them, you can see them all across this field. Here's one. It's a really good one. And it kind of hangs off the top of the plant. The seed head's coming out of here next. It's the last leaf. But it kind of looks like one of those corn leaves that come off the collar. It's going to flap over to the side on the top, and it's going to catch all that sunlight, and it is feeding your seed head. This is why they talk about protecting the flag leaf on small grains. So 3.0 to 3.9. So this is stem elongation until you hit flag leaf. Feeks has several stages in there: 5, 6, 7, 8, 9, because you're forming. You're doing the green up. You have nodes coming out of the ground. There's all these different nodes coming off of here, just like on corn, where we have those collars, just like on soybeans, we have nodes. You have nodes coming up the plant for those stages. Once you get past flag leaf, we get to booting and anthesis. And again, I have a picture of a booting somewhere, but I could not find it anywhere at all. So if you look right in here, imagine this seed head was still enclosed in the leaf, and that's the boot stage, because what happens is you have this swollen top of the plant because the seed head is inside of that plant, but it hasn't emerged yet. Right here, it's already emerged, but imagine if this was still wrapped up inside of the green leaf. That's your boot stage. So boot is Zotics 40 to 49. It's just Feeks 10. You see the Feeks get tighter. Then we have heading, where you have the head fully emerged. Zotics 50 to 59, Feeks 10.1 to 10.5. Stuff starts moving fast now. Tillering takes a while. Green up takes a while. Once we get boot, heading, anthesis, things start moving fast. Anthesis is actually flowering. These are flowers. It's really fun to go out and look at wheat at this stage and take a look. It starts in the middle, and then it moves its way up and down the plant. But that's the anthesis stage, and this is actually when it can get infected at this stage with Fusarium head blights. One of the reasons that we want to be able to stage small grains. Once it's pollinated, you're going to start your seed formation, just like in corn, just like in soybeans. So here you have different varieties of barley. So same thing as in corn, we have a milk stage. We have liquid in the grain, Zotics 7.0 to 7.5, Feeks 11.1. We have a dough stage where it starts to dry down. You can leave a fingernail impression in still because it's dough. Once we get to ripening, it's either you can't dent it or it's very hard. So the seed gets very hard. Zotics 9.0 to 9.9, Feeks 11.3 to 11.4. So you can see with those Feeks, they get really tight. 10, 10.1, 10.5, 10.5, and then 11.3, 11.2. They get really tight in their numbering there at the very end. So the small grains, and obviously I had a lot of corn slides, so I had to cut this short at the end on the small grains, kind of jip you a little bit and slow it down. But the reason that we want to know all these stages, you don't have to be perfect at it. You don't have to be an absolute expert. But for corn, let's say you want to look for certain things. Well, VE is when we know there's going to be seed corn maggot. V4, V8, the reason we want to be able to count those leaves is that's when we recommend you side dress or put your second application of nitrogen out. At V8, typically past V8, there's restrictions on applying glyphosate because it can start to hurt the ear. And VT, if you've ever seen any of our research on tissue sampling or nutrients in corn, it's typically when you go through and grab an ear leaf, right? About VT to R1, you grab an ear leaf for tissue sampling. So recognizing these stages helps you make certain decisions. Same thing in wheat. Tillering, Feeks 3 to Feeks 5, we do split applied N. Feeks 9, you have flag leaf, apply fungicide. Feeks 10 on wheat, we look for Fusarium head blight, you apply fungicide. Feek 11.2, you might put out harvest aids to try to dry down the crop. So recognizing these stages helps us make all these different types of decisions. So I kind of had to fly through at the end there. I was afraid this thing would go over. But if you have any questions, I will be here on the chat. If my kids are yelling in the background, which is likely, I will try to just type in any answers that you might have.